Hello everybody. So in the previous video, we went through the steps to solve the problems related to wedge friction. So let us go through one of the problems here in this particular video. So ultimately, in all the problems all the problems related to wedge friction, you will be finding the magnitude of this external force P. You'll be finding the magnitude of this external force P, which is required to push the wedge inside or horizontally to the left so that the body is being lifted upwards. This is how it goes. Ultimately, in all the problems, you'll be doing the same thing. So let us go through the first problem, problem number 1. So this is the first problem. If you want, you can read out. A block weighing 10 kilonewton is to be raised by a 20-degree wedge as shown in the figure. The angle of inclination of the wedge is given as 20 degrees. Find the horizontal force which is required to raise the block. So consider the coefficient of friction for all the surfaces as 0.3. This is what is given. Value of mu is given as 0.3. Value of mu is given as 0.3. Again, so we have to go through all the steps. There are 3 steps basically. In first step, you'll be drawing an imaginary surface between body and the wedge. And in the second step, you'll be considering only the body. And in the third step will be only the body. You'll draw the free body diagram and then you'll apply the conditions of equilibrium in second step. And in the third step, we'll consider only the wedge, draw the free body diagram, apply the conditions of equilibrium. Ultimately to find the value of P. So finally at the end of third step, we'll get the value of P. So let's go through all the steps. Step number 1 is to draw the free body diagram between body and the wedge. So let us draw, imaginary surface between body and the wedge. Let me draw the imaginary surface. So this will be the imaginary surface. And let us name all the surfaces. Let me name this vertical surface as surface number 1, imaginary surface as surface number 2, and the horizontal surface as surface number 3. So I've marked all the surfaces now. Now, let us go to step number 2. In step number 2, what you are supposed to do, you are supposed to consider only the body. Consider only the body along with the surfaces with which the body is in contact with. So let us consider only the body in step number 2. Only the body. This is the body. So body is in contact with the vertical surface, and we have marked the vertical surface as surface number 1, and body is in contact with the imaginary surface, and we have marked the imaginary surface as imaginary surface number 2. So this is the given body. This is the given body. So we have considered only the body, and this inclination is given as 20 degrees. 20 degrees. This inclination is given as 20 degrees in the top. Now, the self weight of block or body is given as 10 kilonewtons here. Self weight is given as 10 kilonewtons. 10 kilonewtons. So let us start solving the problem. Let me draw the free body diagram for the body. So once you consider the body in step number 2, you'll be drawing the free body diagram, and once you draw the free body diagram, you'll be applying the conditions of equilibrium in step number 2. Similar steps are to be done in step number 3 as well. So once you consider only the wedge in step number 3, you have to draw the free body diagram and you have to apply the conditions of equilibrium. Now, let me draw the free body diagram. In order to draw the free body diagram, I have to draw the coordinates without giving any inclination. That's Done. I've drawn the coordinates now. Once you draw the coordinates, you have to mark all the forces. So first force, what you mark will be self weight. Self weight is given as 10 kilonewton. Self weight is given as 10 kilonewton. So once you mark self weight, the next hidden force which you're going to mark will be normal reaction offered by both the surfaces. Here body is in contact with the vertical surface that is surface number 1, and the imaginary surface, that is surface number 2. So let me draw the normal reaction offered by surface number 1 as N1. Normal reaction should always be perpendicular and directed towards the body. So this is the direction of normal reaction bar. Now let me draw N2. N2 should also be perpendicular to the second surface, and directed towards the body. Let me mark this as N2. So this is 20, this is 90. So this angle should be 70. 70. So you have marked the normal reactions, N1 and N2. So after marking the normal reaction, you have to mark the frictional resistance. You have to mark the frictional resistance. How to mark the frictional resistance is the question now. Now, when you when you push the wedge inside, the trend of motion of the body is to be studied. When you push the wedge inside, as far as this vertical force is concerned, the body moves upwards. Trend of motion of body is upwards. As far as this inclined surface is concerned, trend of motion will be up the plane, up the plane. These two indicates the trend of motion. Let us mark the frictional resistance. Frictional resistance should always be marked in direction opposite to the direction of motion of the body. So here, as far as vertical surface is concerned, body moves upwards. So frictional resistance should be acting downwards. Let me mark this as F1, which is equal to mu into N1. Done. So F1 should be acting down the plane or downwards because body moves upwards. Even here, body, the trend of motion of body is up the plane. So frictional resistance should be acting down the plane. Let me mark this as F2, which is equal to mu into N2. And the frictional resistance F2 should be tangential to the surface. We don't need this. F2 should always be tangential to the surface. So we have marked all the forces now, including the friction resistance. So once we mark all the forces, we have to draw the free body diagram. Let me draw the free body diagram. Mark the self-weight, which moves vertically downwards as 10 kilonewtons. And you can mark N1 here in the positive X scale. And you can mark F1 here in the negative X scale, which is equal to mu into N1. And you can mark N2 in the second quadrant. I'll mark N2 here. N2 in the second quadrant, which makes an angle of 70 degrees. And you can mark F2 in the third quadrant. F2, which is equal to mu into N2 in third quadrant. And inclination of F2 with respect to horizontal should be same as that of the inclination of surface with respect to horizontal, because F2 is tangential to the surface. Surface makes an angle of 20 degrees with respect to horizontal. So this is the free body diagram. This is the free body diagram as far as body is concerned. So once you draw the free body diagram, you have to apply the conditions of equilibrium. Let me magnify and draw the free body diagram. Let me magnify and draw the same free body diagram for your reference. So this will be the self-weight W, which is equal to 10 kilonewton. And this is F1, which is equal to mu into N1. And this will be N1. And this will be N2, making an angle of 70 degrees. And this will be F2, which is mu into N. And this angle is 20. So this is the free body diagram. The same free body diagram which is being drawn again. Now, so after drawing the free body diagram, you have to apply the conditions of equilibrium. Which are the two conditions of equilibrium? Summation of Fx equal to 0 and summation of Fy equal to 0. These are the two equilibrium conditions which you will be applying. In order to apply these two equilibrium conditions, you have to resolve these two forces into their horizontal and vertical components, is it not? So the horizontal component of this force will be minus, because it moves horizontal to the left, minus N2 cos 70. Vertical component will be N2 sin 70. This will be minus F2 cos 20 because it moves horizontal to the left. And this will be minus, because it moves vertically downwards, F2 sin 20. So you have resolved this. Now apply the two conditions. First condition as well as second condition. For the calculation part, I'll be sharing the screen so that you can see the shared screen and understand. It's quite simple. Calculation part is quite simple. So here you go with the question, and this will be the calculation part. And this is the free body diagram which you have. This is the free body diagram which you have drawn here. The same free body diagram is being drawn again, and by applying the conditions of equilibrium. This is the first condition. Summation of Fx equal to 0 is the first equilibrium condition. So minus N2 cos 70 minus F2 cos 20 plus N1, all the forces moving along x direction is equal to 0. F2 can be written as mu into N2. We know the value of mu as 0.3, 0.3 into N2 cos 20 plus N1. Simplify this properly by removing N2 as common factor. N1 is equal to N2 into something. You can find this value. So N1 is equal to N2 into this. N1 is equal to 0.63 into N2. N1 is equal to something, a particular value into N2. So let this be considered as equation number 1. Equation number 1. Now apply the second condition of equilibrium, which is summation of Fy equal to 0. Summation of Fy equal to 0. Consider all the force which moves in y direction. N2 sin 70 minus F2 sin 20 minus 10, which is self-weight, and minus F1, which is this, minus F1. So N2 sin 70 minus, simplify F2 as mu into N2. We know the value of mu as 0.3. Minus 10, again we know the value of mu. And do this. Let us continue with the calculation. Now, once you get this in the previous step, let me just give me a minute. Yes, here you go. Now, by going through this, the last one will be equation number 2. So you have N1 is equal to 0.623 N2 as equation number 1. Substitute this. Substitute the value of N1 as 0.623 N2 in equation number 2. In equation number 2. In equation number 2. So if you do so, you will get this. Substituting 1 into equation 1 into. So wherever you have N1, substitute as 0.3 or 0.623 into N2. This. So if you do so, you'll get the value of N2. We'll get the value of N2 as 15.38 kilo. You get the value of N2 as 15.38 kilo. So this is all about the calculation part as far as the body is concerned. By applying the conditions of equilibrium, we went through the calculation part and we got the value of N2 as 15.38 kilometer. So we are done with step number 2. In step number 2, what you have done, you have considered the body, you have marked all the forces, you have drawn the free body diagram, and you have applied these two conditions of equilibrium, and you found the value of N2 as 15.38 kilometers. So we have completed step number 2. The contribution of step number 2 is this value, the value of N2. Now let us go with step number 3. In step number 3, what you are supposed to do, you are supposed to consider only the wedge. Consider only the wedge and draw the free body diagram of wedge. So wedge is triangular, as you know here. Wedge is triangular and you have an external force P as well. Wedge is triangular and you have an external force P. And inclination of wedge is given as 20 degrees. Now wedge is in contact with surface number 3, which is the horizontal surface. And wedge is in contact with the imaginary surface as well. Imaginary surface number 2. Now this is the wedge given. So once you consider the wedge, you have to draw the free body diagram for the wedge. In order to draw the free body diagram of the wedge, you have to draw the coordinates. You have to draw the coordinates. Yeah. Here, the self-weight of wedge is not given. This particular problem, self-weight of wedge is not been mentioned. So if it is not given, ignore it. Ignore the self-weight. If it is not given, yeah, you can ignore the self-weight. So no need to mark the self-weight here. You can straight away go with the normal reactions. So wedge is in contact with surface number 3. So surface number 3 will offer normal reaction. Let me mark it in this way. Normal reaction should be perpendicular directed towards the body, and let me mark this as N3. And wedge is in contact with surface number 2 as well. So surface number 2 will offer normal reaction, which will be directed towards the body, perpendicular to the body. And let me mark this as N2, and we know the value of N2 as 15.38 kilometers. But we don't know this angle. We need the angle now to draw the free body diagram. If this is 20, this will be 90 and this will be 70. So this is 70, this is 90 and this angle is unknown. So total angle is 180. Total angle is 180. Total angle is 180. So if this is 70, this is 90, this will obviously be 28. 28. Hope this is clear. Total angle is 180 here. This is a vertical line. 70 plus 90 plus the unknown angle should be equal to 180. So finally the unknown angle should be equal to this. It will be 20. Now, so when you push the wedge inside, now it's time to mark the frictional resistance. When you push the wedge inside, the trend of motion with respect to surface number 3, the horizontal surface is, motion of the wedge will be horizontal to the left. So when the wedge moves horizontal to the left, the frictional resistance will be acting horizontal to the right. Let me write this as F3 is equal to mu into N3. Again, the trend of motion with respect to this inclined imaginary surface will be downwards when you push the wedge inside. So when the trend of motion of the body is downwards, so frictional resistance will be acting upwards. Let me name this as F2, which is equal to mu into N2, and we know the value of N2 as 15.3. Right? So we have marked all the forces. Marking all the forces is done. So we have to draw the free body diagram. Let me draw the free body. This is X, Y. So there is no self weight to mark here. There is no self weight to mark. Let us mark all the forces. N3 can be marked here. P can be marked here. This is the external force P. F2 can be marked here in the first quadrant. F2 is tangential to the surface. So surface makes an angle of 20 degrees. So even F2 should make an angle of 20 degrees. F2 is equal to mu into N2. We know the value of N2. So we know the value of F2 as well, if you know the value of N2. Now, N2 can be drawn here in this quadrant. N2, which is equal to 15.38 kilonewton. And N2 makes an angle of 20 degrees. So this is the free body diagram as far as this step is concerned. So this is the free body diagram. Let me magnify and draw the free body diagram, and let me show the calculations. So once you draw the free body diagram, you have to apply the conditions of equilibrium even for this. Let me magnify and draw the free body diagram. X-axis, Y-axis. This is P. This is N3. This can be N2, which is equal to 15.38 kilonewton. This can be F2, which is equal to mu into 15.38. These are the forces. These are the forces which we have. This is 20, and even this is 20. So this is the free body diagram. It's been magnified and drawn. Now, when you have free body diagram, the next step is to apply the conditions of equilibrium. You have two conditions of equilibrium. Summation of Fx equal to 0, and second condition is summation of Fy equal to 0. These are the equilibrium conditions which are to be applied. And ultimately, we need the value of P. We need the value of P. So let me share the screen and I'll show the calculation part. Give me a minute. Here you go. So this is the free body diagram of the wedge. This diagram, same as this. Now, applying the conditions of equilibrium, summation of Fx equal to 0. F2 cos 20. The forces are inclined here, F2 and N2. Both the forces should be resolved into their horizontal and vertical components. And you'll get this first equation which cannot be solved. Apply the second condition of equilibrium. And with the help of second condition of equilibrium, you get the value of N3 straight away. You get the value of N3 straight away as 12.83. So once you get the value of N3, substitute the value of N3 in equation 1 to get the value of P. Substitute the value of N3 in this way. Substitute the value of N3, which is 2 in 1. Equation 2 is N3 in equation 1 to get the value of P, which is the only unknown. So P is 13.51 kilonewton. P is 13.51 kilonewton, which is the unknown which we need, 13.51 5 1. No. So ultimately, in every problem, you'll be finding the value of P. You'll be finding the value of P, which will be the unknown force. So we got the unknown force as 13.51 kilonewton. So let me show you the other problems as well. You can go through the notes. It will follow the same steps. It will follow the same steps. I'll just share the screen and show you the other problems. Just give me a minute. So this is the next problem what you have. Determine the force P that must be applied to a 20 kilonewton block B now to lift another block of 100 kilonewton as shown in the figure. The difference is here block B acts as the wedge, and you know the self weight of block B. Here the self weight of block B or wedge is also given, and self weight of the body is also given. So you have self weight of both. Again, here two bodies are in contact with each other. Two bodies are in contact with each other. So what are you supposed to do? You have to draw an imaginary surface between both the bodies. Consider this surface is surface number 1, this is surface number 2, and this is the surface number 3. Now in step number 2, consider only the body. You have considered only the body, and you have drawn the free body diagram. You have drawn the free body diagram of only the body. Now applying the equilibrium condition for the same. You have to apply equilibrium condition. You'll get equation number 1, equation number 2, substitute 1 into and get the value of N2. Same steps, get the value of N2. And in step number 3, you'll be considering only the wedge. This is the wedge, what you have considered, and you'll be drawing the free body diagram of wedge. So this is the free body diagram of wedge. This is the free body diagram of wedge. Once you get the free body diagram of wedge, apply the conditions of equilibrium. Summation of Fx equal to 0. Summation of Fx equal to 0 will give you one equation. And summation using summation of Fy equal to 0, straight away will get the value of N3. Substitute the value of N3 in equation 1 to get the value of P. So this is the second problem what you have. This is the second problem. So go through these two problems as far as wedge friction is concerned. You have some other problems which are being solved in the notes. You can go through those problems as well. So let us continue with ladder friction in the next video session. Thank you.